So now the topic I want to go into is a more formal definition of percent increases and percent decreases. Percent increases are like taxes or getting a percent raise. Percent decreases are like going and finding a sales or a discount, basically the same thing. So generally, when we talk about percent increases, we talk about how things are going up, prices going up, values going up. And then percent decreases would be the opposite direction. It would be obviously going down. And unlike, I had an example earlier in one of my videos of finding a sales tax and finding the total cost of the item. And I called it the eighth grade style. So what I want to do now is create a formula that will work much better solving these and also gives us a way of going backwards. The eighth grade style, there is no way of going backwards to get a previous answer. So we have to come up with a different method. So let's start with percent decrease this time since we did percent increase last time. We'll do it eighth grade style, and then I'll show you where the other idea comes from. A store has 15% off everything sale. How much will be saved and how much will an item now cost when it was originally $38? So the eighth grade way is you start off with the percent. So the first thing we're going to do is change 15% into its decimal value by dividing by 100. So this is its decimal value. Then we're going to multiply that by the cost of the item. So we're going to have 0.15 times $38. So 0.15 times 38 is 5 point. So this equals 5.7. Now we're talking about money, so I'm going to put a zero here and a dollar sign in front. So the discount is going to be $5.70. All right. And then the eighth grade style would be, let's find the cost of the item now. So you'd turn around and take $38 and you would subtract the $5.70. So that would be 32.30. My math might be a little bit off here, so I'll double check it. All right. So it's a two-step process when we do it in this style, and we can't really go backwards. We can't go from the $32.30 and come back up with the 38 doing it this way. There's no nice way of doing it. So let's change this into algebra. So for example, if I went through the eighth grade style with just X dollars, you would see something a little bit different. It's nice using a variable because then we can see what's happening to the variable rather than up here where everything disappears and becomes numbers. You take two numbers, shove them together, and it generates a new number. But you can't do that with variables because the variable is unknown. So sometimes it makes life a little bit nicer. So we would start off by multiplying 0.15 times x, and this would be our discount. Oops, not an m. And then we would take that number, this would pretty much represent the $5.70 up above, and we would subtract it from the original cost. So it would be the original cost minus my discount. And this would be the final cost. We're going to call it the new value. I'll put it up here, new. So the new value is going to equal x minus 0.15x. Now, algebra-wise, if you have 3x plus 2x, you've been taught that that's equal to 5x because of like terms and all that fun stuff. But a lot of people forget that there's something called the distributive property, but we won't get into that. This one is x minus 0.15x. So what we would do is the same thing. Up here we went 3 plus 2 to give you 5. Here you're going to go 1 minus 0.15, which is 0.85. So this would leave us with 0.85x. And we would get 0.85x is the new cost. So if you double check this with $38 and you did 0.85 times 38, so 38 times 0.85. It's $32.30. This gives us a different way of doing it. And this way of finding out a item's cost, generally with a sale, you don't really care how much you're saving. What you really should care about is how much are you spending. So the other way of going about this is to take the 15% that they originally gave you, subtract it from 100%, that leaves you 85%, and use that percent just to multiply the price, and it gives you your final answer. All right, let's take it a step further now. So let's go one step further. Now, when we're talking about this, we have the original cost, and we have the new cost. So I want to come up with variables or letters that represent these so I don't have to write out these entire words. So if we call this one the new cost, N, I'd love to call the original cost the old cost, but the problem with calling it old and representing it with O is O looks a lot like, well, 0. So I usually use G for grandma, because in my mind, grandmas are old. I don't know why, but that's how it is. At least mine was when I was a kid. So I'm going to use N for new cost and G for the old cost. So, and the percent, I'm going to represent with X. So I'll be writing things like X%. All right, so with those variables in mind, let's take, find new cost given sale of X%, and of course the old cost, the original price. So I want to find the new value based off a sale of X% off some original price. All right, so we'll go through the same steps. We're going to first change the percent into a decimal. Now, I can't really do much with this. X over 100 is just X over 100, so that's my percent. So this is my percent step. Step 2 is to take that and multiply it by the original cost. So I'm going to have G, the original cost, times that percent. Okay. Step 3 says, well, now I'm going to take the original, G times X over 100, and subtract it from the original cost. So I'm going to get G minus G times X over 100. And then this is what's going to equal the new cost. So my formula kind of looks like this so far. N equals G minus G times X over 100. Okay. So this is where algebra comes in handy. Notice there's only two terms on the right-hand side. Both of them are G's, or have G's in them. So those are my two terms. And since both of them have a G in them, they can combine like terms. And the concept is called factoring. So what I'm going to do is I'm going to rewrite this as N equals, and I'm going to kick out the G. Now when I kick out the G, I'm going to divide by it. So I'm going to get inside G divided by G minus G times X over 100 divided by G. Oops, that's not a G. G. So if I distributed it back out, the G's would cancel, and we'd be back to, well, this expression. But I'm trying to get away from that expression, so I'm going to leave it the way it is. And on the inside, I'm going to get G on the outside. G divided by G is 1 minus. These G's are also going to cancel, and you're just going to be left with X over 100. So this becomes known as the percent change formula. So here I've written it twice. Generally, I usually just put a plus or minus and write the formula once. But I wanted to be really clear about something. So this formula is called the percent increase. So that means that your percentage is going to be represented by a positive number. This one over here is a percent decrease. And therefore, we're representing it by a negative percentage. So if you're dealing with a percent increase, you want to make sure that it's 1 plus x over 100. And if you know your numbers are going down or decreasing, then it's 1 minus x over 100. All right, let's do an example. George makes $15.50 an hour. His boss told him he was going to get a 17% raise. Good for him. How much will George be making now? Okay. Now you could do this the old style, but I want to get used to these two formulas. Now, first off, it's a 17% raise. So out of the two formulas, a raise is more of a percent increase. I wouldn't want his salary to be going downhill, which would be a percent decrease. So I'm going to be using this formula, and it's really important because later on we're going to be dealing with lots of formulas. And one of the first steps of dealing with a formula is writing it down first. A lot of people skip this step, but it becomes kind of important because then you have to go one letter at a time and say, do I know this? So, do I know George's new salary? And the question is, no, that's what the question is asking. So, generally, if you read the question, it tells you what the unknown is, and you have to be really cautious about where you put your numbers. Then I can ask, do I know the old value, the grandma part of the value? And the answer is yes. This number up here is going to represent G. And then X, of course, becomes the percent. So this right here is going to be the X. So it's really important to recognize your variables first before you even start with the formula. Because if you just start plugging numbers in, you will make a mistake most of the time. All right, so N, we're going to leave it alone because we don't know it. G was the 1550, and you can drop the $sign, and you can even drop the 0 if you want. I'll leave it. 1 plus, and you just write the percent as the percent, so 17 out of 100. That's really representing a percent. And then all you have to do is type the right-hand side into the calculator. As long as the variable is on the other side of the equation, and this junk here is all numbers, then you can just type it in a calculator. The problem happens when numbers are on both sides of the equation. Then you can't just start typing things into a calculator too quickly. All right, so we'll type that into my fancy calculator, 1550 and 17. Oops, this one. 1550 and 17. So 1550 times 1 plus 17 over 100 is 18. Now this is money, so it's going to be $18.14 when we round it. So this will be $18.40. So his new salary is going to be $18.40 per hour. And that would be a 17% increase on his pay. Not bad. All right, Mary also got a 17% raise, but for some reason she only knows that her new pay will be $21.20 an hour. What was her pay before the raise? Now, this is the question that you cannot do the old 8th grade style. There is no way of backing out 2120 by 17% to come up with the old pay. You can't take 17% of 2120 and then subtract it from 2120 to go backwards. It doesn't work that way. So we're going to have to use the formula for sure on this one, where the new value is equal to the old value. We're talking about a pay raise again, so it's going to be 1 plus. If she was getting a pay deduction, which is very rare, it would be 1 minus. And then the percent is going to be written as x over 100. All right, so let's go start looking for the variables in this problem. So she got a 17% raise, so that's going to be x just like before. It's going to be positive because it's a raise. Then we know her new pay is going to be $21.20. So that's going to be N in this case. So the biggest mistake people make is this N. Sometimes it'll use 2120 as the old value, and that'll mess up the formula completely. So you have to be really careful. This is a new value, so you're going to have to put 2120 in the spot of N. So 2120 is equal to, and we don't know the old value because we're looking for the pay before she got the raise, which is the old value. And then 1 plus 17 out of 100. Now, if you want, you can change the 17 out of 100 to 0.17, and then 1 plus it is 1.17. And that's basically what I'm going to do in the next step, because I really can't type much into the calculator here. I have a number on the left-hand side, that 2120, and I have a variable on the right-hand side next to another number, 1 plus 17 over 100. So it's better to simplify the numbers on their respective sides, if you can, before you go to any other steps. So I'm definitely going to add 1 plus 17 over 100. And this is G times 1.17. All right. Now, algebraically, to solve for G, I need to get it by itself, and I have to undo the multiplication between G and 1.17. So I'm going to take both sides and divide by 1.17. And when I do that, I'll get G by itself, and therefore I'll know the old value. So G is going to equal 21.20 divided by 1.17. Let's see what my calculator says. So 2120 divided by 1.17. 18.12. So her old pay was $18.12 per hour. So here's an example for a discount. I just made it up, so I don't think this ever really applies. A car dealership will give an 8% discount when buyers put a $5,000 deposit on their car. The Smiths will be putting $5,000 on a car, so they qualify for the 8% discount. And the car costs $23,500. So what they want to know is how much will the car cost after the 8% discount. So we're going to use the discount formula, which is new is equal to the old grandma, 1 minus, because it's a discount, x over 100. Okay. So then we start searching for the variables that are necessary for this formula. So I start usually with a percent. So I have an 8% discount, so that means it's going to be the negative x, part of the formula. The $5,000 deposit is irrelevant to this problem, so it's just an extra number that we can ignore because it was only a condition to get the 8% discount. So the $23,500 car is going to be one of the prices. Now, is it new or is it old? So when they put this $5,000 down, they're going to get 8% off of this price. So this price here is the old one. So this is going to be G. And we're looking for how much does it cost now. That's obviously going to be N. So again, I want to reiterate, labeling the variables before you plug them in is really important. All right, so N is going to go here. The 23,500 is going to go here in place of G, parentheses 1 minus 8 over 100 for the 8%. All right, so this one is the type where all the numbers are in the right-hand side. So you just need to type this into your calculator. 23,500. Make sure you put a parentheses in your calculator, otherwise it's not going to give you the right answer. But you can type it all in one fell swoop like this and get our answer of 21,620. So the cost of the car is going to be 21,620. Let's look at this example and see what happens. Here I have the pandemic increased the number of unemployed people in the United States by 660% to 38 million people. How many people were unemployed before the pandemic? So sometimes articles will tell you things like this, that it increased by 660%, and it tells you what the answer is going to be, but it doesn't tell you where it starts from. I wish they would give you all the pieces, but oh well. So let's see what we can do with this one. So we have a formula, n equals, new equals grandma, old, 1, and since we're doing an increase, it automatically tells us that this is going to be a plus x over 100. All right, so let's go looking for what each one of these letters is represented by, and if one is missing, that's the one we're looking for. Sometimes you might want to start with a question. How many people were unemployed before the pandemic? So before would be the old value. So my question is looking for the old. So when we get to this 38 million people, this one is going to be the new one because that's the value it increased to, all right? So that leaves our 660%. Of course, that's going to be x. So let's plug in what we know and solve for the unknown. So the new value, I have 38 million. Now, you could write the 6 zeros that follow it, or you could write E6 for the scientific notation of 38 million. But if you just leave it as 38, then you just have to remember that when you get to your answer down lower, it's going to be in the millions. And you have to be careful of questions that if they already are asking for things in the millions, you don't want to change it to a million because that would change actually the value of it. All right, so we have 38 there. We're looking for G, so I'll leave him alone. It's a percent increase, so it's 1 plus. And I'm going to write 660 over 100. So the first thing I need to do is, well, there's numbers on both sides, so this is not a straight calculator type question. I'm going to have to simplify the number next to G. So in a calculator, I'm going to have to type in 1 plus 660 divided by 100. So 1 plus 660 divided by 100, 7.6. So I'm going to come back over here and write 38 equals G times 7.6. Now, the operation connecting the G and that 7.6 is multiplication. So if I want to get G by itself or solve for G, I'm going to divide by the number that's next to it, which is 7.6. So 7.6 divided by 7.6 is 1. So on one side, you're going to get G, and I'll flip the equation a little bit. And I just have to figure out what 38 divided by 7.6 is. So back here, 38 divided by 7.6 for a grand total of 5. So my answer is 5, but this is not 5 people. This is 5 million people were unemployed before the pandemic. So it went from 5 million people to 38 million people in a matter of a few months. All right, this next thing is another reason that I like what I call the grandma's formula. New equals old, 1 plus x over 100, is it derives the other formula that we need without having to just say, this is how it works. So I like doing it this way, showing you the algebra and showing where the formula comes from. But in the end, you really just need to know the formula at the end. But I wanted to show you that it actually does pertain to what we've just been doing. So I'm going to distribute the G back through. So, G times 1 is G. G times x over 100 is going to be a plus G x over 100, times. And then I'm going to kind of start solving for this x up here. So if I start solving for that x, the easiest thing to move is going to be that G, the loose one here. So I'm going to subtract G from both sides. Now, since everything is a letter, I'm not going to be able to combine like terms more than likely. So I'm just going to write them next to each other. So this becomes new minus old. is equal to old times x over 100. Okay, and then I'm still trying to get this x by itself. So the next thing I can move easily is the g again, but in this case it's g times x over 100, so I'm going to divide both sides by g. Entire side over here by g. Alright, so now I'm down to new minus old divided by old is equal to x over 100. Now remember, x over 100 is another language for x being a percent. So my next step is to get x by itself, and when I do, I just have to remember that x was a percent to begin with. So to get x by itself now, I just need to get rid of the divide by 100. So the opposite of dividing by 100 is multiplying by 100. So I'm going to multiply both sides by 100, the only number in the formula. All right. And I'm going to flip the sides around. So I'm going to write x on the right-hand side. I remember that it's a percent, and it's going to equal new minus old over old, all times 100. And we're going to make sure my answer is a percent, so I'll put it in parentheses. So this formula is what's called relative change. And it's kind of dangerous when you read it in like news articles and they say things like, in New York there was a 5% increase in pay or something like that. But the problem is then we don't know what the original pay was, and we don't know what the ending pay was, so it's really not enough information. If the article was well written, it would at least give you one of those numbers. But so many people use percents kind of freely without thinking about, you need to know at least one more piece of information to make it at least worthwhile. All right, so this is what's called relative change. Now, before relative change should be this thing called absolute change. And absolute change is probably the simplest thing. Absolute change, I'll write it up here, is just the top part of the fraction. So it is just the new minus old. That's all relative change is. All you're doing is comparing an old value with a new value and coming up with what's called absolute change. Now, when the absolute change is positive, you're going to have a percent increase. When the absolute change is negative, then you're going to end up with a percent decrease. And you're going to have to note that on the percentage itself. So if you have new minus old as a negative number and your percent becomes 5%, you only have two choices to write it. One choice is to write it as negative 5%, so it would be a negative 5% change, or you label it as 5% decrease. So it's a negative 5% change or it's a 5% decrease. And they mean the same thing, it's just one is written with a negative number and the other one is written with a positive number, and then the word indicates that it's going down. All right, so let's look at this example. Last summer, 14 students took this class. This summer, there are 22 students. What is the absolute change in the students? And you have to be really careful about reading the question. Here we're looking for absolute change. It could just have easily been relative change. So make sure you answer the question that is posed. So absolute change is literally just new minus old. So that's all we have to find is what is the new value, what is the old value. So when we look at this 14 students, this was last summer, so this one must be the old number. And then this summer, there are 22 students, so that one must be the new number. So we're going to get 22 minus 14. And it makes sense because that's what, 6, 8? We have 8 new students, or 8 more students than we did last semester. And that would be a positive relative change when we get to it. Now let us find the relative change in the students. So the formula for relative change is this. I'm going to write it a different way. Instead of n minus g, I'm going to actually write the words in. It's not a very algebraic formula. It's more of a placement formula. So when I put in my numbers, and I'm going to do it the whole way just in case you didn't find absolute change first. But if you did find absolute change, it just goes in the numerator. So the new value was 22, the old value was 14, the old value was 14, and then we're going to times this by 100, and because we're multiplying by 100, that changes it into a percent. All right, so a little caution about this formula if you did not do the absolute change first, is if you type this into your calculator the way it looks, and I'll just do the new minus old over old part, this will get you to the wrong answer because your calculator is going to see this first, and it's going to calculate it first by the order of operations. Division comes before addition and subtraction. So this would become 22 minus 1, so your calculator is going to spit out 21, which is definitely not the right answer. So to make sure that you don't make that mistake, you have to understand that when you see a long fraction bar, it is an old notation for parentheses. So I highly suggest you put a parentheses in front of the 22 and after the 14. So when you type it in your calculator, it should be 22 minus 14, divided by 14. And then here you can actually times it by 100, and on paper change it to a percent. So parentheses 22 minus 14, parentheses divided by 14. So parentheses 22 minus 14, parentheses divided by 14. That gives us 50.57 something. And then you're going to multiply that by 100, and that'll change it into a percent, 57.1. So we're going to get X percent is about 57.1%. Because it's positive, it's a percent increase. If it was negative, I wouldn't write the negative, and I would just write the word decrease. All right, another example. A store grossed $12,380 this month. Last month, the store grossed $17,500. What is the relative change, also known as percent change, of the gross income? Now, gross is just how much money came into their register, basically. All right, so again, this is a percent change or relative change, and the formula is X percent equals new minus old over old, times it by 100, and on paper, change it into a percent. Okay, so we need to know the new and the old here. So when I read this, the store grossed $12,380 this month. So that's the current gross income. And then last month, it grossed this much money. So when I say last month, that becomes the old value. And then this month becomes the new value. And those are the only two numbers that I can plug into the formula, so I'm all set. So here we go. X percent is equal to the new value of 12,380 minus 17,500 for the old value. And it's really important that you get the old value correct because that's also what you divide by. And then we're going to times that by 100, change it to a percent. All right, so remember, on a calculator, you have to be really careful. It needs a parentheses before the 1,200 and after the 12,000 and after the 17,000. Okay, so this becomes parentheses 12,380 minus 17,500 divided by 17,500. and then we're going to multiply that by 100. So really small, it's a negative 29.3. So this X percent is going to be a negative 29.3%. So the way I'm going to answer my question is it's going to be a 29.3% because it's negative decrease. And there's my answer. Their income or their gross income went down by 29.3%.